Hello and welcome to section 1.5, infinite limits. And so in this section we are going to talk about what happens if the graph goes to infinity. And this is one of the ways the limit does not exist, so we're going to kind of talk about what's going on here. So here I have an example to start with, and so here is the graph, here is the equation, 3 divided by x minus 2 into my calculator, and so when I graph that, I get a picture that looks something like this. So when we look at this picture, you can see that if I find my limit as x approaches 2 from the positive side, that would be going like this, you will notice that the answer to my limit in this one is positive infinity. You will notice that as my graph goes towards negative, or 2 from the negative side, I get negative infinity. And you'll notice that this vertical line right here is actually a vertical asymptote, and we'll talk about vertical asymptotes in a matter of moments. And since these two limits do not approach the same value, you would end up with it does not exist. Now, you may be asking yourself at this point, what happens if I had a graph that, say, maybe both of them went up to positive infinity? Well, if the graph looked something like this, say we have a graph and our function does this, and we have a vertical asymptote and something like that, and so as we approach our value c, we get the same infinity. Then when you get down here, even though it still doesn't really exist, it doesn't actually approach a y value, you could say that it would be infinity, and it would be just as good an answer as it does not exist. And we'll talk more about this one in class. So then we have a definition of a vertical asymptote, and we've dealt with vertical asymptotes for many years at this point in time. And so basically what happens is a vertical asymptote is the function approaching infinity or negative infinity as it approaches the value of c. So as it approaches some value and the graph goes up to infinity or down to negative infinity, it is what we basically are defining as a vertical asymptote. Usually these appear when we are dealing with rational functions. And so when we have something like 2 over x minus 2, we had that function in the previous one, or something like 1 over 1 over, if a function is something like where it would both go up, would be something like 1 over x minus 2 squared or something to that effect. They'd both go up, and so vertical asymptotes are basically appearing when the bottom is equal to 0. And so that's really what we're talking about, is that what you will find as we do these, before, when we were dealing with rational functions, if we ended up with 0 divided by 0, that meant that we had to do a little bit more work to find out what the function was as it approached that value. Well, when we get this time for vertical asymptotes, those will appear when you get a number over 0. And so as soon as you get a number, something other than 0, over 0, you'll end up getting a vertical asymptote. And we'll talk more about this also in class, so please make sure you get these down. And then we have our properties of infinite limits, and these properties are probably starting to look familiar to you because we've seen them so many times. And basically what we're saying in this one, we have some limit as x approaches c of our function, and this one is going to go up to infinity as we approach. So this would be a graph where, probably like I showed you the second one, where they both went up. So as we approach this c value, which would be our vertical asymptote, we get positive infinity. Well, over here we have a function that approaches g of x that approaches some value, say like 4. Well, if that's the case, if you add those together, infinity plus 4 is still going to be infinity. If you multiply them together, infinity times 4 is just infinity, or negative infinity, just depending on, it also depends on what the L value is. You can change it. And then last but not least is probably one of the more important ones, is if you take a function, some value, and divide it by infinity. If I take 4 and divide it by the biggest number I can think of, just as many zeros as I can possibly write out, this is going to be a really, really, really small number. So we're going to say that's pretty much equivalent to 0. And then all of these properties hold true pretty much for negative infinity. And so just make sure that you get these down so that when you come to class, you're ready to go, so that we can talk about them and also use them in our examples.